When factoring polynomials, always begin by checking for a greatest common factor first. So if I take a look at this first polynomial, I have an a in the first two terms, but not in the last two. I have a c here and here, but not here. I have a d here, but not here. And I have a b here, but not here. So there is no variable that is common to all four terms. So there is no greatest common factor in this one. And then if we have a polynomial with four terms, we can factor it by reversing the foiling process. So I'm going to begin by setting up those brackets, and I know that a binomial times a binomial will initially give me those four terms before I can sometimes simplify them into a trinomial. So in this case, there are no like terms. We can't simplify this any further. If you happen to have a squared term, it helps to put that term first, but I can see in this example there is no squared term. So we're going to reverse this process. F stands for the product of the first two terms. So if I multiply this term times this term in the brackets, I'm going to get one of those terms. The order doesn't really matter here, but let's maybe just start with the first term. So in order to get AC, I can multiply A times C. That product will give me that term. All right, so now O stands for the outside. So we're going to multiply A times something to get one of these terms. So we can see the only other term with an A in it is AD. So I'm going to put this plus D there. And then when we multiply the outside terms, that will give us the AD term. And then I stands for the inside terms. So C times something is going to give us one of those terms. And I can see this is the only term with a C in it. So we're going to go ahead and fill in the B. When I multiply those inside terms now, B times C gives me that BC term. And the last term is a check. So if I multiply the last term times the last term in each bracket, I should end up with the remaining term BD. So quickly FOIL this out. We're going to have AC plus AD plus BC plus BD. These are the factors that represent this polynomial. So in our second one, we're going to begin by checking, is there a greatest common factor? So there isn't, and my squared term is already first, so that's good. Now the order doesn't really matter here. Sometimes you will have to rearrange the terms, but we're going to go ahead and set up our two brackets for the binomials, and then we're going to begin with our squared term. So we're going to say what times what will get us back to that y squared, and we can try going y times y. The product of the first two terms will get me back to that y squared, and then the outside. So y times what will give me one of these other terms. Now we have a choice here. We can either put in 8x or we can put in a 2. So take a look at the other terms because we also know that we're going to have a y times something here as well. So in this case, let's just try maybe the 8x. So we can multiply y times y and get the y squared term. Y times 8x will give us that 8xy. And then we've got the inside terms here. So we've got y times what will give us one of these terms. Well, this is the only term with a y. So let's go ahead and enter the 2 here. So we multiply the inside terms to get 2y. The last term is a check. 2 times 8x is 16x. And then quickly FOIL this whole thing out. So we've got y squared plus 8xy plus 2y plus 16x. So these are the factors of this polynomial. When we multiply these together by FOILing, we will get back to that. In our next one, we can see that the squared term is already first, and we don't have a greatest common factor in here. I can't remove an x because this last term doesn't have an x, and there is no number other than 1 that will divide evenly into those four numbers. So we're going to begin by reverse FOILing, set up our two binomials, and then we're going to say, what could we multiply together to get 8x squared? So let's say that we try an 8x times an x. Now, if we multiply 8x times something out here, we have to get one of those other terms, and we can see that 8 is not a factor of those other three numbers. So this is not going to work. Are there two other numbers that we could multiply together to get 8 that are going to be factors of the remaining numbers? And we can see that we can also break 8 into 4x times 2x, and now if we do the outside, is 4x times something going to give us one of these other terms? And we can see that we have a negative 4x here. So because this is a positive 4x, I can put a negative 1 here. So we now have negative 4x, and maybe let's go ahead and check this off. So there's the first term and there's the second term. We have two terms left. So now the inside is 2x times something going to get us one of those terms, and we can see that 2 times negative 5 will give us that negative 10x term. And again, your last term is a check. So negative 5 times negative 1 is positive 5. Watch your signs closely. So then quickly FOIL this out. So we've got 8x squared minus 4x minus 10x plus 5. In our next one here, again, we don't have a greatest common factor that's common to all four terms. So I'm going to leave x squared as my first term, even though we have another squared term here, because 5 is a prime number, whereas 18 is a composite number. So I know that the only numbers that will multiply together to get back to 5 are going to be 5 and 1. So we can go ahead and set up here 5x times 1x, that's the first term. And then if we multiply the outside, 5x times what will give us one of those other terms? Well, we can see that the only terms with an x are this term and this term. 5 is not a factor of 6. So 5x times what will get us to this negative 15xy squared? And we can see that 5 times negative 3 gets us negative 15. We've got the x, we need the y squared. So that is now that term. And so you can see we're not necessarily going to go in order here. And then we're going to say x times what will give us this one? Well, there's no x here, so let's take a look here. And we can put a negative 6 in there. That will give us that one. And now our last term is a check. Is negative 6 times negative 3y squared going to give us 18y squared? And it does. So this is factorable. So we've got 5x squared minus 15xy squared, that's that term there, minus 6x, that term there, and then we've got a positive 18y squared. So this will FOIL out and get us back to that polynomial we were given. And finally, we have another four terms. There is no greatest common factor. My squared term is first. So let's go ahead and see if we can factor this. We're going to set up our two binomials. We know when we FOIL them out, we should get four terms before simplifying. My squared term is first. So what times what gets us to 2a? Well, 2 is a prime number. So I know that I have to have a 2 times a 1. And I'm also going to have a and a. I'm not going to leave this as a squared because I can see that there's no other term with an a squared here. So I'm going to have to split up those a's. And then 2 is not going to be a factor of 3 or 9. So let's look at this one. So 2 times negative 3 will get me that negative 6. I've got an a, I need a b. So let's go ahead and fill in negative 3b. So we've got the product of the first terms and we have the product of the outside terms. Now the inside, a times what will give us one of those remaining terms? Well, this is the only one with an a, so let's go ahead and put in the negative 3, and then check, is negative 3 times negative 3b going to get us that positive 9b term? And then quickly FOIL, 2a squared minus 6ab minus 3a plus 9b. We did it. We now have some brackets within our polynomial. So I'm going to remove those brackets by distributing in that 3x and then that 5. So we end up with this. We now have a four-termed polynomial. There is no greatest common factor. My squared term is first. So I can go ahead and set up these brackets. Now again, 3 is a prime number, so I know 3x times x will get me back to that first term. And the only other number that 3 is a factor of is this negative 12. So I'm going to go ahead and put in a negative 4 there. I've already got the x, so the product of my outside, 3x times negative 4, is that negative 12x. And then the inside, we have x times something. Well, this is my only term with an x, so we can put a 5 in there, and then check on the last term. 5 times negative 4 is negative 20. So this FOILs out to get us to this, and then I want you to notice something. X minus 4 is the factor that is common to both of those. So we can have a binomial that is a greatest common factor. So that's that factor. And then we take this 3x and this plus 5 and we group them together in another bracket. So if you're asked to FOIL something, FOIL means that we are creating those brackets, we're creating those factors. If the original polynomial already has the brackets in there, check to see, is the bracket the same? If so, that is a factor common to both, and then we can group what's left into another bracket. So in the next one here again, we can see that we have brackets. Factoring means we're creating brackets. If I were to distribute that 4x in and that negative 7 in, I would end up with 4 terms. Let's try to reverse FOIL this and see if what we think is happening is actually happening. So we don't have any greatest common factor in here. I also don't have a squared term. So when I go to figure out what could I multiply together to get this, well, I don't want to break 4 into 2 and 2 because 2 is not going to be a factor of 7. So I can see that I have a 4 and an x in the first term. I also have a 4 and an x in the second term. So let's maybe start there and say, okay, let's go 4x, and that leaves me with an a over here. 4x times a is that first term, and then 4x times what will give me another term? Well, here we go. So I'm going to have a negative b here. So that's the product of the outside terms. And then I have an a times something. Well, this is the only term left with an a. So let's go ahead and fill in the negative 7. The last term is a check. Negative 7 times negative b is that positive. And again, notice, A minus B is a factor common to both. A minus B is a common factor. We're then going to group together that 4x and the minus 7 into another bracket. These are the factors of this polynomial. In our next one, I've gone ahead and distributed in the A and the 5 to get rid of those brackets. Again, we have 4 terms, so I'm going to set up my binomials. We don't have a greatest common factor. We also don't have a square term. So let's start saying, what can we multiply together to get that ax? So let's go with a times x, that's my first term. And then a times a negative y will get me negative ay. X times a negative 5 will get me that term of negative 5x, and check negative 5 times negative y is positive 5y. So we have ax minus ay minus 5x plus 5y. So that's going to get us back to what we have here. Now, in this particular question, we don't have the same thing in brackets. This is a positive x, this is a negative x. This is a negative y, and this is a positive y. Both terms have the opposite signs from one bracket to the other. So let's go back up here for a second, and because this first bracket has the x and then the y, I'm going to take this second bracket, I'm going to take this negative x and I'm going to put it first in the bracket, and I'm going to take this positive y and put it second in the bracket. And now x minus y is what we have here. So if I want this to be x minus y, I'm going to factor a negative 1 out of this, and that's going to change this sign here. So instead of a positive 5, we're now going to change this to a negative, and we didn't change the question. If I were to distribute this 5 in, 5 times negative x is negative 5x. Negative 5 times x is still going to give me that negative 5x term. 5 times y, which is what we originally had, 5 times y is 5y. If I have negative 5 times negative y, I still will get positive y. So we did not change the question. We just pulled a negative 1 out of this bracket, and that changes this sign here. Now you can see that we have the same bracket, x minus y, that's a factor common to both, and then we have the a minus 5, we can group together in the other bracket. This process is called factoring by grouping. So if you are asked to factor a polynomial and you already have brackets in that polynomial, check to see, are those brackets the same? If they are, that bracket is common to both terms, so that becomes one of the factors, and then group together what's in front and put those into the other bracket. So we don't actually need to be distributing it all. I just wanted to go through that process to show you how this works, but you can go from here right to here. So I see the brackets the same, that's one factor, group together what's in front, that becomes my other factor. If the terms are the same but both signs are different, and both signs have to be different, you can pull out that negative, flipping this sign, and then that becomes your other factor. And one last one just for fun here. So we've got 5a. I've distributed that into the brackets along with that 2c. So I can see that I have a 5a and a 5a. So let's try putting 5a here, and then I can multiply that by m. That will give me my first term. And then in terms of the outside, we've got a 5a, and let's try putting an n here. That will give me the second term. And then here we have an m. We need a 2c in order to get that next term. So let's put in a 2c. Check the last term, 2c times n. Well, this is a negative 2cn. This is a positive 2cn. So this is not factored properly. Let's try this again. So I can see we've got a 2c and we've got a 2c here. So let's maybe put in 2c, and now I can multiply 2c times m to get that term. So 2cm will give me that term. And then 2c times a negative n will get me that last term. So we can fill in the negative n there. And then we've got an m here. This is my other term with an m, so we can put in the 5a, and that inside product will give me that term. The last term is a check. 5a times negative n is negative 5an. This is positive 5an. So again, this is not correct. You can keep going, but no matter what we try, we will not be able to FOIL it back in order to get this. So just like we call a number with only two factors, one times itself, a prime number, this happens to be a prime polynomial. There are no two factors that we can multiply together to get back to what we were originally given. I can't just change this sign to a minus like we did here, because if I change this to a minus, I'm going to have negative 2cm. That's now changing the original question. So here, both of those x and y's had opposite signs. Here, m is positive, m is still positive. It's only the n that has the different sign. And just one word of caution, if you have a summative assessment and it asks you to factor completely and gives you a variety of polynomials, I've in the past had students who put prime, 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 prime for almost every question on the page. Very rarely are you going to come across a polynomial that doesn't factor if you're asked to factor. So be aware it does exist, but it is not overly common for what you're going to be given. We're able to solve problems using the greatest common factor. So anytime we're creating groups and we don't want to have any leftovers, it means we're dividing a number evenly into another number. If we're looking for the maximum number of groups, that's the greatest common factor for the numbers we're given. So we have some Canadian coins here. The largest number that we'll divide evenly into 18, 30, and 48 is 6. If we have 6 groups of toonies, so 18 coins divided into 6 groups means there will be 3 toonies per group. If we have 6 groups of loonies, so 30 coins divided into 6 groups means that there are 5 loonies per group. And if we have 48 quarters, we divide them into 6 groups, we will have 8 quarters in each group. A toonie is worth $2, so if we have 3 of them, we have $6. A loonie is worth $1, so if we have 5 of them, we have $5. And a quarter is worth 25 cents, so if we have 8 of them, we have $2.